Hey, hello everyone. Thank you for joining today's Tips and Tricks webinar. Today's topic, as you can see, is on the value of full mesh networks with SASE private access. Please use the Q&A chat if you have any questions. We'll make sure we get to those at the end of the webinar. Our presenters today is security engineer Michael Massa and security architect Larry Taylor. Guys, what do you have for us today?
Thank you, Rob, and thank you all for joining. As mentioned, my name is Michael Massa, and I'm based in Bristol, Rhode Island. I'm joined today by Larry Taylor, who is one of our Harmony security architects. Larry and I have recently had a few conversations with some customers where SASE private access has been the answer to some challenges. And so I invited Larry to the session to discuss the value of a full mesh network with Harmony SASE. We'll cover the evolution of SASE, private access architecture, followed by a demo. Then after that, we'll hit the Q&A. With that, Larry, I hand it over to you.
Hey, thanks, guys. So today we're going to start with just a little bit of, how did we get here with SASE, right? We hear that terminology, secure access service edge. It's all about trying to move that perimeter closer to the end user and those devices. And so, if we look at that evolution, we started off with that on-premise data center, pretty standard. We had a firewall there at the perimeter. We have that remote access VPN connectivity, whether that's terminating on the gateway or a VPN concentrator, that sort of setup. We have some remote offices. We're probably doing some VPN tunnels between those. And then, as the world and network evolves, we start getting these cloud workloads. We start moving things out into some of the public cloud sectors, and we have to figure out now, how do we secure those? So we start using firewalls in the cloud. Those may be the same vendor. Those may be the cloud vendor provided firewalls. And then we realize that, there's all this danger of just browsing the web, right? We have so many malicious websites. We have malware. So how do we protect our users in those remote offices and stuff when they're browsing the web? So we start introducing potentially secure web gateways and things like that to protect that browsing traffic. And then we also, right, as time evolves, as a society, remote work has just, been put on our laps, right, with the pandemic. Remote work was forced on us. Some people, had it beforehand, but it's really become our way of life now in some way, shape, or form, whether that's a hybrid remote work, or we just have the flexibility where we're doing more work at home even after we've been at the office. So how do we secure that, traffic? And then again, as our networks get more complex and we need more security, we introduce lines like MPLS circuits, which are costly, and where do those terminate? What's the best path? A lot of times their speed is slow. We can get so much more performance, through internet circuits and things like that. So the complexity just continues. And then you layer on, the management on top of all of that. And we're really dealing with what we call that network complexity trap. As you can see, the workloads are everywhere. We're dealing with so many more locations. People are working from everywhere. And how do we pull that all together and manage it? So that's really where SASE has evolved from. So the first thing SASE addresses is private access. So how do we get those remote users back in to the data center securely, right? VPN and IPsec VPN tunnels, they're around. A lot of times those clients are cumbersome. A lot of times we don't have good, methods for deploying that client or even having an inventory of that client. We also struggle with authentication and making sure we have that VPN authentication secured. A lot of times we're using a local, radius database. We aren't using multi-factor. We have multiple logins. We're not rotating passwords. things like that, where, now as we move into that SASE environment, we can do more securing with tying in with identity providers like Okta, Azure AD, or Entra, Google, things like that, so that we give that user experience that single sign-on, one authentication, and we can have that one source for identity. Along with that, if we have that source already tied in with multi-factor scenarios, we automatically can provide that multi-factor authentication specifically on our remote access methodology now. Now, the second piece is we can start tying in that internet access, and you can see that we start bringing those things out from the data centers and bringing those into this cloud service. And with internet access, we have the ability to secure that internet browsing no matter where they're at. And you can use that consistent policy, whether they're working from a Starbucks or a hotel or working from home. So we really can help, with that. The other thing this allows is, the ability, we want to leverage SD-WAN, maybe for those MPLS circuits, maybe for multi-internet circuits. And then we also want to be able to centralize that management and consolidate those solutions into that single resource. So in the end, what does that look like for us? It's Harmony SASE, a great as a service solution where you're not having to do capital asset expenses to keep your hardware up to date. We're not having to provision that out in all these different locations as our workforce is getting more globalized. And it just allows a lot of flexibility. And as we dive into that, you'll see where that's coming from. So the other thing we offer, which is unique in the marketplace, is one of the challenges with SASE on the internet access side is around the having to tunnel that internet traffic through that cloud. There's a few things. One is latency scenarios. The other is localization, right? Because if, for example, I'm sitting in Indiana, and if my cloud location is Chicago, when I search for restaurants around me, I'm going to get results from Chicago because that's where I'm egressing the internet. So what we've done is we actually have a hybrid internet access scenario that we support, which allows you to tunnel some traffic into the cloud for internet. So we can do things like whitelisting of our SaaS applications. So if we want to secure and tighten up that entry point to, say, Office 365 or a Salesforce or something like that, we certainly can. But general browsing, we just want to, protect those sites and implement some URL filtering. And we want to just make sure we're not visiting those malicious sites, those phishing sites, things like that. We can still egress that local internet, get those localized results while still protecting that browsing session. So just kind of a quick list. These are high level. Everybody has different use cases. These are some of the more common ones and kind of higher level. What I will tell you is every conversation I get into with customers, usually we're focused on one of these to start with. And then all of a sudden, as we talk through the environment, we talk through what you're doing for your remote users and the tool sets you're using, we always seem to find additional. So this is really kind of like the Swiss Army knife of networking, in that there are a lot of things and a lot of use cases that we can solve with SASE. And it doesn't mean you have to adopt them all. A lot of times they can be implemented one step at a time. And you can grow the use cases and the usage of a solution like this. So let's talk a little more today. We're going to focus on the private access. We're not going to drill into the internet access today. So when we talk about private access, let's talk a little bit about what we're talking about. So there's two methods to private access. One is going to be the agent-based. These are going to be more corporate managed machines. So we have an agent that gets installed on that machine, and then we can support communication back to resources in any cloud, any data center. but we're going to support all ports, all protocols. So we can support applications with custom ports. We can support your standard ports, and we're going to be able to build policy on what can be accessed. We can support, all platforms. So Windows, Mac, Linux, Chromebook, iOS, Android. So even in those mobile scenarios, we can support remote access back to those resources. So, if you have an intranet site, or you have a site that is currently publicly available, but is really for internal use only, this can become a way to help secure that, right? I can close that hole on my perimeter, not have that public DNS, not have that public IP available, even in a NAT format coming through my firewall. We also have an agentless scenario. So this is really a good use case for things like contractors, where you can't support or can't require them to install your software. How do you keep the agent up to date? And so these are going to be more of specific application sets, right? We support things like RDP, SSH, VNC, web protocols, right? HTTP, HTTPS. And it allows us to give you a secure method into your environment without having to, again, have those holes at your perimeter. And then one of the big things with Sassy is the zero trust framework and supporting that zero trust network access. So with that, we want to validate the identity, and that identity is going to be tied to an identity provider, so that you aren't dealing with that standard localized password and having to maybe that password is not on the same password change frequency as what your corporate credential is. And then we also can support the modern MFA cycles because they're supported within those identity providers. In addition to that, on the ZTNA framework, it's not just about the user auth, right? That's the first step. We verified, and we're doing a better job now of verifying that user identity. But how do we make sure that that hasn't been a compromised account and that somebody's accessing that from a company machine? So we do support posture checks of the device itself. So we can do checks, for example, of things like, hey, there's a certificate on the machine. It's joined to an Active Directory domain. We can also do checks for versions, or that it's running your antivirus software, different things like that, so that we can help make sure that that machine is secure before it's accessing the network. And then, of course, inventory management. We do identify who the user is, what devices they're coming from and accessing from. So we have that tracking as well. Now, the title of this was the value of the mesh network. So let's talk a little bit about our mesh network. And this is really the value of Harmony Sassy, is we have built out this mesh network across the globe. And here in a few slides, I'll show you kind of a map showing where some of those locations are. So we've got over 70 locations across the globe where we have infrastructure. And in that infrastructure, we have internet access. We have our gateways where we're doing policy inspection, but we also have our management layer where we're managing those policies, keeping track of any policy changes. What are the categories of URLs that you're blocking? What are the resources and ports that you are allowing into your data center, and things like that. Now, the key here is kind of represented in this big sphere is the fact that we have a high-speed backbone interconnecting all of those. So no matter where you enter this network, we're able to route you to the closest region that you're subscribing to. So let's say, let's just use this example. I'll just use myself for an example. If I'm a remote user and I'm working in Indiana, maybe my closest location is going to be Chicago, but maybe my data center is located in New York. Well, instead of me connecting directly to a VPN in New York, I'm able to access Chicago. Now, in that regard, I'm going to be routed across that backbone straight to that data center that's in New York. But now what happens if I try to access a resource that's located in AWS and it's in my West Coast and it's in Chicago? Well, traditionally, I would route into that data center, and then I would have some kind of haul into my AWS environment, and I would be transported across that. In this regard, I'm going to come in. I know that that resource exists out on the West Coast in AWS, and I'm going to route directly to it. Same thing with branch office locations. If I have those connected in, I would route directly to those locations no matter where they're at. So it really is bringing that routing out in front. I'm no longer relying on that data center to be my only point of routing. Now, if we, again, just another slide talking about that backbone. So again, when I come in, I enter whatever pops. So if I travel, one time I might be connecting to Chicago. If I go out west, I might be connecting into Denver. Either way, I'm going to hop on the backbone, you know, with the most efficient pop based on my location. And that is an algorithm that we have that we do for you. This isn't like your VPN client where you go, well, I want to connect to this office. Okay, well, now I traveled, I went overseas, I'm going to connect to this office. That is all done automatically for the user. And then the routing is done to those resources automatically as well. And all of that traverses our backbone that we manage, minimal latency, SLA backed, and just gives your users that optimal experience no matter where they're going. You know, we also have those connections directly into the data centers for a lot of the cloud providers. So we can route you directly in there very efficiently as well. So this is just a quick map, you know, showing you kind of geographically where a lot of those locations reside. What you're going to find is, you know, pretty much everybody has a location. This is continuing to grow based on customer need. But this is, you know, what I find talking to customers is we generally have a location wherever your office is, wherever your population of users are working. So let's just dive in a little tighter on the architecture. So this is just kind of, you know, I like pictures, and so this is kind of just going through, you know, a traditional IPsec client split tunnel architecture. So again, I have my VPN client. My internet traffic, if I'm in split tunnel, is just going directly out to the web wherever I'm going. A lot of times I lose that protection, and then I send my VPN client, my IPsec, I'm terminating in a data center. And then from that data center, I've got all my routing to whatever my locations are going to be with my traditional WAN. So what you'll see is if we flip that now and we leverage Sassy and we have that hybrid mesh network in place, you'll see that with split tunnel, my general internet browsing, I'm going to send out to the internet, except I'm doing inspection on that to secure that traffic. But then I also have the ability to even split my internet. So I can define and send certain resources in so that I could securely go out the internet. And why would I do that? That's because I can egress any of these locations. You have internet at any of those, you get a dedicated static IP address. So I can now whitelist things like Office 365, Salesforce, those types of SaaS applications, so that I can only log in to Office 365 or that SaaS application if I'm coming from one of my whitelisted IPs. So if I have somebody who's randomly compromising an account and trying to access that, say from, you know, Germany, that user won't be able to get in. The authentication will actually be denied, even if they have account credentials, because they're not coming in from an appropriate location. And then you see we have our private access going in. It's going to be routed out to the appropriate location immediately, so that, again, I don't have that extra layer where I'm hopping into the network and then having to, be routed on that WAN. I'm also not having to backhaul all that traffic. So if I'm trying to do things like SSL inspection, if I'm trying to do, all traffic coming in here, a lot of times customers have to increase the equipment that they're using. They have to increase the bandwidth that they're using for those locations. And this really helps you not have to do that. So it might prolong a refresh cycle, might keep you in the same level of gear with better functionality instead of having to uplift and upgrade equipment. All right, so now we're going to jump into a little bit of a demo here. So I'm going to just kind of start with our management console. So all of this is managed from the Infinity portal. If you're not familiar with the Checkpoint Infinity portal, this is our single cloud management console, which manages all of our product portfolio from one interface. And it supports all the things you want from a secure web portal. It's going to support, single sign-on. It's going to support MFA, all those types of things. Role-based access control, all supported across those different applications. So the first thing you see here is you can see we've got some traffic flows, what my device distribution is, things like that, just a nice overview. But we're not going to spend a lot of time on that because we're really going to focus in on the network today. So you can see from a team member perspective, I do have users. You can see that I'm pulling those in from Azure AD. I also, because we support SCIM provisioning, I've pulled in groups, and my group membership is all managed from my IDP and my identity provider as well. You can see I do have device inventory. So I can see what user, what device, what their authentication is, what their posture status was, and things like that. And we won't dive into profiles and posture checks, but you can see this is where we have those. What we really want to drill into today is network. So the way we build out that network is you're going to define your network name, and then we can do things like I want to manage who can access this network. So I can assign a group. Here you can see I have mine open to all users. I can define firewall rules. So this is where I can define what user group is going to access what resources in what location. I can define split tunneling or full tunneling. We also have private DNS. So as we start building out a network across multiple locations, multiple regions, maybe I want to use my internal DNS with that localized region, right? So I could come in here, and I can also here define a regional DNS. So this region might be different from a secondary region as far as those DNS queries. Now, what we're looking at here is we define our network with a region. So first off, you saw that map. First, we're going to pick a region, and the region is the geographic location, right? Could be New York, Chicago, could be Denver, could be wherever, right? Any of those locations we identified on that map. Now, when we add a region, you automatically add a gateway, and that's because we need the gateway to be able to do that policy inspection. Again, we mentioned that you get a static IP address with the gateway. So for every gateway I install, I'm going to get a public IP address that I could use in that whitelisting. The next piece here, what you're going to see is that connection to my data centers. So in this example, I have an AWS VPC, happens to be located on the East Coast, and I have a secure IPsec communication. Notice that this is actually, there is no public DNS. These are all outbound initiated. So we do not have to have holes in our perimeter firewall or anything like that to allow this communication. Now, how do we know where to go for resources? Well, when I look at the tunnel, just like defining an IPsec tunnel, I am defining my endpoint, and then I'm defining the subnets and networks that reside in that location. So if I enter and I'm being routed to anything in that 192.168.12 network, I'm going to hop in and I'm going to be routed. Now let's look at a little more complex network. This is just my demo lab. So I don't have as much going on, but let me show you one that looks a little more complex, and you can kind of see how this works. So in this scenario, we've got a location in New Jersey, Denver, Chicago, Ashburn, North Carolina. And so I may have users from different regions where their agent is connecting into those different regions. Now, each region has a gateway. You can see here that New Jersey, I actually have 2 gateways defined. In this scenario, maybe it's a load perspective, because we can do some load scenarios. All that would be front-ended with load balancers. It could also be I want to do some redundant tunnel type scenarios. Now you can also see that how we route. So if I'm accessing resources in AWS VPC1, I'm going to be routed through New Jersey. So if I'm a client that enters Chicago, this is representing that high-speed backbone. So I'm going to come into Chicago, I'm going to be routed straight to New Jersey, and I'm going to go across this gateway where that tunnel is connected, and I would access AWS VPC1 resources. And vice versa, if I'm in New Jersey and I'm trying to access SKLab 1, right? I would traverse that backbone and be routed across that IPsec tunnel to SKLab 1. Now, what happens if a location goes down? Well, my client is, if a location is down for whatever reason, that algorithm is going to redirect me to the next closest location that's active, and I would still be routed out. Now, if there is a tunnel that's only into one, obviously you could have an outage, but that's where it's important to do redundant tunnels and redundant gateways and things like that, just like you would build out a network. The difference is I can build that redundancy out with the flexibility of movement. I can build this out with the flexibility of not having to have that upfront capital expense. Again, this is all as a service. So all I have to do is go in, and I don't have any more licensing available, but you just go in, add a location or a gateway to your network. You can see here, I don't have a license, so I can't add it, but all I do is add a gateway if I need an additional one in New Jersey. Well, what happens if I have something? I actually talked to a customer one day, and they said, well, every year, we have a large group of attorneys that go on this one event, and we don't really have any infrastructure out there. Well, in this scenario, let's just use an example. Let's say that event is out in, let's say they're in Las Vegas. So all I would do is spin up for that period of time a region for Las Vegas, add a gateway, and that would allow them to immediately hop on that backbone and be routed appropriately. So I could have that remote location spun up in about 10 minutes is what it takes to provision a new location and a new gateway. Think about this from a DR perspective. Today, right, when we build out those VPN configurations, we have redundancy built into our VPN, into our DR location. We have all this equipment that we're paying for that's just sitting, right? We're paying for licensing duplication. We're paying for equipment duplication. Well, in this scenario, I've got DR built in. I can build out these tunnels in a redundant fashion. I can have multiple regions. And so in the event that any point fails, I can still be routed across this mesh network into any of those locations, even if we have a scenario where there's a location down. So, I can have those types of scenarios. So let's take a look just a little bit closer, right? We're getting up on time. So the other thing I wanted to show you is just a little bit from kind of that user experience, and talk about that. The other thing I will mention is smaller offices with this mesh network. I have a customer that has a lot of very small offices, and today they put equipment in every one of them, but they don't host any resources there, but they're paying for firewalls and licensing. Think about this, treat it like a Starbucks. If you now have all your policies in that mesh network, whether that user comes into one of those offices or whether they're working at Starbucks, their security level is the same. So that's where that consolidation, that's where that TCO can really come into play. So let's look at this. Here you can see I'm running a machine out in, to be honest, this is in Azure, running out on the East Coast. What you're going to see is I'm accessing my localized network. So when I look at the client, let's just pop this open here. So you can see I am connected to that mesh network that I have defined. You can see I'm located and I'm connected to New York Gateway. I have a public IP address from that gateway, but I have an internal IP address. So when we build that mesh network, we assign a subnet just like you would. Now, what's that allow us to do? Take this beyond the remote access play. I can now route across that mesh network, even from my data center, say to a branch office. So maybe I have some option there to transition some of my WAN circuits, and I don't need to pay for some of those, private circuits, because I'm going to be able to leverage some of this for that communication. Maybe it's an administrative communicate out. Well, if all my users get an IP, I can do remote control type scenarios across my mesh network outbound. If I have an internal voice over IP phone system, we can do soft phone transfers out to those users through this subnet, because they now have an IP on that network. So let's look at what that looks like from a user perspective. So here you can see I have ICMP. Oh, you know what? I didn't show you the firewall policies. I apologize. Let me back up here, and let's just look at some of the controls we do have in place for this example. So here you can see the policies we have in place, and you can see we have things defined like a specific server that I'm allowing RDP to. I have a file share with SMB access. I have an intranet site where I'm allowing HTTP. And then I'm allowing to the entire subnet, I'm allowing the admin's ICMP. So if we go back to that machine, you can see that my ICMP is working. Now we have a default deny on the firewall on that gateway. So while I can ping 12.32, let's say I try to SSH to it. So here I'm trying to SSH to 12.32, which is a valid Linux box. You're going to see that it is going to time out and we're blocking that traffic. So we're not able to get there. Now, we can also access that file share because my permissions allow me. You'll see I can open files, I can copy files. So I can work with my file shares just like I'm sitting in the office. I can also do things like access my intranet site. So you'll see here that intranet.taylorsecurity.org is going to that 12.37. So let's just pop that open. Oops. And when I go to the intranet site, you can see that I can access that. If I need to, I also have RDP available. So I can use those internal IPs and I can connect directly into those. So that's a little bit about the value of the private network, both for remote access, but also keep in mind, it can also help you in some WAN adjustments and changing that network architecture as you go through your network transformation. So with that, Michael, back to you.
Thanks, Larry. We'll move it over now back to Rob for the question and answer portion of the
Yep, we
presentation.
got some good questions for you here. Thanks, guys. First one, do you provide dedicated egress IPs for the Sassy cloud? For example, so I could use those dedicated IPs for trusted conditional access rules for Office 365.
Yeah, great question. So that is what I was showing. Let me pull this back up here. So when we look at, I'm just going to use this one because it has more devices. So yes, this IP address on this gateway is yours and yours alone. This is dedicated. This is static. It does not change if we have to restart that gateway. That is the static IP. And for every gateway that you utilize, you have that IP. So all these IPs would be the list that you would use for that trusted conditional access.
Okay. Next question. I've got remote users across the country. Would you set up regions for every hire?
Yeah, I would say no, right? This isn't necessarily meant to be a one-on-one. Just like, for example, I'm working out of Indiana. In this scenario, I would connect to Chicago. It's close enough, especially at the speed of networks. Now, if I had an office, and especially if I was, hosting resources there, or a larger population of users, I would definitely want, to have a location there. So, if I had more of an East Coast, West Coast, or I had a region where I had maybe a lot of remote users being hired, I would want to spread those around, but it's not, hey, I have one person that's located in this state, I should have a gateway there. I would do it more regionalized from that perspective.
Okay. Next one. I know Checkpoint acquired Perimeter 81. What is the difference between the two consoles? One says Checkpoint Sassy, the other Perimeter 81.
Yeah, great question. So you're correct. Last fall, Checkpoint did acquire Perimeter 81. So this connectivity platform that you're seeing here today is the Perimeter 81 platform. The first thing we did, so this was when we initially acquired them. We do still have customers that are using the Perimeter 81 management console, but all new customers are utilizing the Infinity portal. Everything is the same. You can see there, everything is the same. It's just, as this is all brought together, as we're going through that integration of bringing them on board, we've moved the management into the Infinity portal. So the only reason I was showing this one was just because I had more gateways, more regions that I could show, but that's really the only difference.
Got it. Next question. Do you need SD-WAN functionality to make SASE work, or can this product run without the SD-WAN license?
Yeah, great question. SD-WAN. So SD-WAN is not a requirement at all. SD-WAN is, when you look at the Gartner definition of SASE, a SASE vendor, to say they have a SASE solution, has to support SD-WAN scenarios. So there are customers out there that at certain locations, certain offices want SD-WAN, but it is not a requirement. If you don't have it today and you don't have a requirement or a need for, that level of, inspecting jitter and transitioning lines and steering traffic and things like that, it is not necessary, but it is supported if you do have that need.
Okay, great. I think that covers all the questions. So thank you guys. Great information. As always, we'll send the follow-up email with any reference content, and a recording link for this session. Our next webinar will be in 2 weeks. That one is going to be on cloud WAF security. So you'll see the invitation for that soon. With that, we'll let you guys go. Larry, Mike, thanks again. And we'll see you all here next time. Enjoy your day. Thanks all.
Thank you, Rob.
Thank you.
Bye.
There you go.
Thank you.